Can you guys hear me okay? All right, cool. So thanks everyone. Today I'm going to be talking about DevAttackOps full stack red team. And kind of before I even get into it, just know that it does come with an open source project. So if at any time throughout the talk you want to check out what it actually is that we're talking about, please feel free to go to the GitHub link and check that out. So who am I? I'm Quaid DeLacluyse. I go by Ezra Buckingham, so if you look at anything cyber related and you see Ezra Buckingham, that's me. I'm the only Quaid DeLacluyse on the internet. I like to keep it kind of separate between the world of red team and Ezra. I have some certs, but like HR only really cares about those, so I won't tell you about them. I joined cyber back in January of 2021, so I'm still kind of green to the industry. However, I've got a lot of different background that gives me a leg up as a red teamer. And I am a red team operator at Fifth Third Bank. We're based out of Cincinnati, Ohio. However, we kind of have a presence out everywhere. So if you want to learn more, come up and talk to me. So general disclaimer before I get into the actual talk. All the opinions are my own, not the opinions of my employer. Do good, not evil. The thing that I always tell my teammates and all my friends is play stupid games, win stupid prizes. So if you want to go play that route, go for it. But I am not accountable for anything you do. And then the other disclaimer is kind of more about the talk. What I'm going to be talking about is not a new problem. A lot of red teams, a lot of people face this problem. So my solution was built around the needs of me and my team. Your team might have different needs and thus need a different solution. So today, I'm going to talk first about kind of the goals of my presentation, the goals of the research I was doing. Talk about kind of my journey, so where I started with a project called the Red Baron, the implementation that came along with the Red Baron, and how I tried to adapt the solution, reframe the problem, and then I'll introduce you to Terry, which is the solution that I came up with. So first, let me talk about the goals here today, as well as for my research. So my goal as a red teamer was I wanted to develop a red team infrastructure pipeline that is cross-cloud capable, user-friendly, extensible, and secure. And when you start to think about all those adjectives, you're like, okay, those are kind of catch-22s. You're not really looking at these things and saying like, okay, I can have all of those things. But that was my goal. So my goal here as a presenter today is to take you on a journey of how I seized an opportunity to automate my workflow, learn how the cloud works, learn how to automate infrastructure creation and configuration, and then learn how to abstract away the cloud using open source tools. So like Tim talked about this morning, I wanted to be lazy. I did not want to really have to manually do things. So I want to take you through my journey of how I got to be really lazy and came up with the solution that I have. So if you're in the audience and you don't fit the red teamer, I understand that not a lot of people are red teamers, so I want to make sure that you all feel like you can answer some questions as you go along with this presentation. So if you're a red teamer, you might ask yourself the question and be able to answer, how can I remove the minutia from setting up operational infrastructure and still have badass emulation capability? If you're a sysadmin, how can I automate configuring and building infrastructure? If you're a developer, how can I integrate conflicting solutions together? And if you're none of those and you're not really sure what you're going to get out of this, I want you to walk away with the answer to the question of how can I tackle complex problems and abstract solutions away from their implementations? So let me set the stage for you a little bit as far as what my kind of dream state was for red team infrastructure. So I sat down and I thought to myself, and also there's a QR code. I know there's a lot of hackers in the room. Don't scan the QR code. There's also a URL. But the QR code will take you to the wiki page for the GitHub where you can find all this information because I know it's small. So my goal was I sat down and I thought to myself, here's what I want out of a red team infrastructure pipeline. So I wanted to make sure that all of my malware communications would come from my victims. They would hit basically domains that are registered in various cloud providers. Then all of it would hit a reverse proxy. And then all of the traffic would go from that reverse proxy through a VPN tunnel to something that might be in a private network. Right? And then all of that, I want it all logging off into an Elastic stack that I own. Right? And that was like the dream goal. That was the thing that I was working towards with doing all this research. I wanted to get to this. And that was kind of the genesis of how I came up with the solution that I have today. So let's first talk about where I started. So let's talk about the Red Baron. What is the Red Baron? It's a project originally from Coalfire Research. It's a set of Terraform modules for kind of cloud resources, all with a red team focus. And it's actually now owned by a developer called ByteBleeder. and it's recently archived as a project. And as we start to get through it, you might start to recognize why it was recently archived. And I also will say this is going to be very like DevOps heavy. So if you don't follow any of these terms like Terraform, just think of infrastructure as code and configuration as code. That's essentially what I'm going to be talking about. So when you dive into the Red Baron, like I said, it's a bunch of cloud modules all with a red team focus. So as we start to look at these modules, we see Azure, AWS, DigitalOcean, Google, Ansible, and some other fun things. And all of these, if you look at them, we see all these different types of resources that we might want to deploy as a red teamer, right? So we have a really great start of where we want to go. And the way my team used this was we had all of these kind of cookie cutter red team operational infrastructure Terraform files. And inside of that file, we would instantiate each Red Baron module depending on what we really wanted to have in our operational infrastructure. So fun fact, a .tf file is Terraform. So whenever you see a .tf, think Terraform. So the workflow for me was first, we would make a new directory on a server that we owned. In this case, we make the super secret operation that's going to hold our Terraform files. We'd run certbot for all of our domains that we wanted to use for the operation to make sure that we get SSL certs set up for all the domains we were using. And we do it with wildcard certs for HTTPS. Then we would take one of those cookie cutter templates, take the variables.tf file, we'd put it into the new folder we created, we'd edit the variables.tf, and then we'd edit the actual kind of cookie cutter different red team operational template that we had, run Terraform init, run Terraform apply, and then we'd SSH into each server, echo out public keys, private keys, so that all of my team had access to all the infrastructure we stood up. And then we'd manually install and configure C2 and other software. And we'd have to rinse and repeat this for n number of servers. And if any of you are sitting in the crowd, again, this is where I go back to Tim's talk. I am lazy. I don't want to do this. This sucks. So then I sat there and asked myself the question, does this scale or adapt? And yes, I have so many aliases, so sometimes I like to think that I'm talking to myself. It's very weird. But the answer to that is no, it doesn't. But it's a great starting point. It gave me all the things that I needed to know to understand where I wanted to kind of make my new vision of what I would be building towards. So this is where I started to think about the Red Baron, and I was like, you know what? I have a really great starting point. Let's try to adapt this solution. So as we start to look at the Red Baron and really kind of scrutinize what we're looking at here, we see each module inside of Red Baron consists of 0 or more of servers, domains, DNS records, CDNs, or even tools. But I was constantly asking myself the question, why repeat the resource or tool definition by the resources use case or provider? So what I mean by that is if we look at just an HTTP redirector, like we're not reinventing the wheel, that is defined for all of the cloud providers. We have one defined for Linode, one defined for DigitalOcean, one for AWS, one for Azure, one for Google. And let's say you wanted to scale out another cloud provider, you would now have to repeat that tool definition. So my new vision was, you know what? That's not going to fly. I want to now have a base module for each fundamental resource for each cloud provider, and then have module variables to control which Red Baron module to load. Again, I didn't want to rebuild all of the Terraform modules that were already in that project, but I wanted to have logic inside of the Terraform module to dynamically set the source module I was going to load. And then a little bit deeper was the way that the actual servers were configured is a provisioner called remote exec. So remote exec, think about that as just you manually SSHing into a server and deploying a bash script and running the bash script. That's essentially what remote exec does. And what that would have done is then I could migrate all of that remote exec into Ansible playbooks, and that would remove all my code duplication. So now I don't have the HTTP redirector code duplicated across all the different cloud providers. I have it managed in one single Ansible playbook. So what this implementation looked like, and I'm going to call out before I even talk about it, is line 19. Pay attention to this. This is important. So I would have on the right-hand side what the actual module would look like. That's the kind of agnostic module. So it would be server.tf for any cloud provider, and then inside of it I have a locals block that has basically all my mappings for all the different cloud providers, and it would tell me, okay, if the user provides me AWS, I want to load module AWS EC2 instance. If someone provides me DigitalOcean, I want to use this module. And you see, I didn't get very far, and that's very intentional because you'll see why. But essentially in here, I have a little bit of logic being performed saying, okay, here's the instantiation of that module. If I'm loading the source of modules agnostic server, and I want it to be cloud provider AWS and server type HTTP redirector, then I can start to dynamically load the different Red Baron module based on what a user input. And getting even a little deeper, cloud providers don't configure servers the same way given the same operating system. So if you're deploying a system in AWS, you can only SSH in, so again, I'm talking about Debian, you can only SSH in as the user admin. But if you're on DigitalOcean, you can SSH into the user root, right? So now we have some more discrepancies that we need to fight based on the different cloud providers and how they actually give you a server. But as you see, what we have here is this is the instantiation, this is the module, and again, pay attention to line 19, because when you actually try to do this, it doesn't work. What you see is Terraform will yell at you. It will say variables are not allowed on that line 19. You can't use variables in that source definition. And of course, I'm a red teamer, right? And I was looking at my teammates and I'm like, haha, I got you guys. I'm a hacker, I can bypass this. And that's when the devastation kind of continued, and I realized, I can't do that. Because I went to the Terraform GitHub, and I saw that someone was asking for this exact same thing, and one of the contributors came back and said, that does not work. You cannot do that. This is where I had to extremely hard pivot, because I did not have the tools that I needed to go build what I wanted, given the current solution. So this is where I had to reframe the problem. My problem stayed the same, but I had to rethink about how I was looking at it and think, what do I need to make sure that I can achieve my vision, but maybe a different way? So when you go back and look at the implementation that I was trying to build out, we again have our server, agnostic server module. And if again, look at 919, what I'm really trying to do is have dynamic Terraform files. And that kind of drives where I started to go, because I asked myself the question, can I dynamically generate code? And of course, the personalities in me were then trying to answer this question. And yes, it's weird to talk to myself. I know my team makes fun of me all the time. And the answer is yes. It's called templating. It was a totally new concept to me. I had not gone down into the world of templating before, but this was kind of the magic bullet that I needed to achieve that question of, can I dynamically create Terraform files? And for me, I was really comfortable with Python. So that's where I started using a templating engine called Jinja. So Jinja is a templating engine that's built into Python. It's a library. And what that allows me to do is build one resource type for each cloud provider, and then dynamically inject parameters using Python and the Jinja templating engine into that template. Right? So this gives me way more control in Python than in something like HCL, which is the programming language for Terraform. Right? So now I have way more flexibility, and I have the power of Python behind me rather than trying to hack solutions together inside of Terraform. And this is where I call it like the turning point for me, because I now knew where my new vision was going to go and where it was going to take me. And this is where I'll introduce you to Terry. This was the solution I came up with. So my new vision had evolved from where it started, and now I wanted a base template for each fundamental resource for each cloud provider, so a server, a DNS record, an SSH key, and maybe some other things that I can't think of at the moment. And then I wanted a command line interface to render each template, build the infrastructure with Terraform, map that state back to an Ansible inventory, and then run playbooks against each host. So instead of doing all that remote exec provisioners and repeating that code across all the different cloud providers, I wanted to have one playbook to go build the things and have me never have to touch it. And then kind of the cherry on top was I wanted to use Docker to deploy containers onto the host that just work. And I'll talk about that in a little bit. So if you're a little lost, I totally understand. And from this new vision, this is where Terry was born. And this is the logo for Terry, and here's the GitHub project. So if you want to go check it out, feel free to. There's a lot of development that I'm still doing on it, but this is a good start for where I wanted to go. So what the hell does Terry do? The Terry is your command line interface. What Terry will do is, based on the arguments that you pass into the command line, it will dynamically render some Jinja templates, which generate valid Terraform code. Then Terry will do a Terraform build. So if you decided you wanted to build something in Azure, something in DigitalOcean, something in AWS, Terry will go build those things for you. And then take that data from the Terraform state. So after you build it, you hit all the cloud APIs, you now get a bunch of data back saying, oh, here's the things I built. And then you can map that state back to Ansible and then run some plays. So total baseline thing that I wanted to do was I wanted to set up some firewalls. I wanted to provision user access. I wanted to install some different tools. I will talk about Nebula. That's a fun project. I wanted to set up elastic logging, which I will not talk about because that is a whole day-long conversation, and then deploy some containers. Right? So this is the vision that I had, but let's break it down because that's a lot. Right? So let's kind of break it into little chunks where we can talk about each piece. So let's first start talking about Terry rendering some Jinja and doing some Terraform build. So the way I tackled this problem was I wanted to make every single thing into a configuration file so I didn't have to make any code changes, but I also wanted to have all these resource templates kind of mapped out like we had in the Red Baron, so you can look and see exactly what I have available to build. So the Terraform implementation looked like basically everything is in its own folder based on the cloud provider. So if we're building a specific resource like a domain, a server, or an SSH key, that would be inside of each cloud provider folder. And then I'd have a provider configuration to say, okay, if I'm using AWS, I want to use this Terraform dependency because you need to tell Terraform that we're going to use these specific packages to build specific resources, what version to load of that provider, and then what credentials I needed to then interact with that API. So for AWS, you need specific keys like the AWS access key ID, the AWS secret access key, and the AWS default region. And there's some other pieces here that I'll talk about in a little bit, but that was the general configuration. With those two pieces of data, I can now have a command line interface to wrap around all of those things and say, if I'm building this type of resource using this cloud provider, I want to render this template, spit it out to a Terraform plan. Now I have everything that I need to go build the resources that I've asked Terry to go build for me. So now, once you go build the resources, you need some way to take that data back from Terraform and map it to an Ansible state or Ansible inventory and run some plays. So what did that look like? That again goes back to my provider configuration earlier. So inside of the provider configuration, I now have a block for servers, and because each cloud provider, when you're actually building things in Terraform, they have totally different nomenclatures for the exact same pieces of data. And I wanted some way programmatically to go through a Terraform state for each provider and say, here's the data I need given this data point I'm looking for. So when we're talking about a server in AWS, that reference or that data point inside of the JSON of the Terraform state is AWS instance. And the remote user that I can sign in as is admin for AWS. And to get the public IP v4 address from AWS, it's public_IP. And that changes across each cloud provider. But I needed a way to basically say to Terry, if we're using this provider, go look for this data in the Terraform state, map that data back to an Ansible inventory, so now I can run some plays against it. Great. Now, I have a valid Ansible inventory. I have all the resources built, but I need to run some plays against it and actually do the things to configure a piece of software on the system based on what definition I have in the CLI or maybe in my config file. So I started off with, okay, let's just talk about literal base configuration. And then I can then target different host groups that I have inside, that I have defined via the CLI, and target those different host groups to then install different software based on the needs of that specific resource. So talking about literally just prepping a baseline server, I might want to create user accounts as defined in some sort of config file, allow SSH key auth, disable password auth because I care about OPSEC, install a host-based firewall, UFW, and deny all traffic except for 22 TCP from the red team public IP addresses. And that's important because I didn't want to lean on any firewall implementation of any cloud provider. So AWS, we have this concept of security groups. But if I'm deploying cross-cloud, now I have to manage all these different types of firewall implementations across all the clouds. But if I do a host-based firewall, I can do everything on the host and not have to worry about it. And then, if I have it configured, I can install something like Nebula. I'll talk about that. And then install FileBeat. That is my Elastic Stack logging structure. And that I won't get into, but there are other ways that you can kind of research that and see exactly how that implementation is done. Then I started asking myself the question, what if I want to install a very custom type of software on the server, but I had maybe conflicting dependencies, maybe port collisions. So let's say I have a HTTPS server and I want to install Cobalt Strike. Now we're having resources trying to be hogged by different software. So Cobalt Strike might be looking for 443, Apache's looking for 443. So now I started asking myself, how can I manage installable software using a single config file and get some more flexibility from that? And that's where I then answered my question of, yes, I can. It's called Docker and Docker Compose. And this, again, was a totally new concept to me. So don't butcher me if all the implementation is wrong. However, it works for us, and I know that the understanding of Docker and Docker Compose is sound for the use case that I'm looking for. So if you're not familiar with Docker and Docker Compose, let me talk to it a little bit. So Docker is a software that allows you to build software packages into standardized units called containers. Doing so allows you for a build once, run anywhere mindset, and containers will run the exact same way no matter where they're deployed, right? So now I don't have to worry about, oh, will Cobalt Strike run in AWS, or will Cobalt Strike run on Debian 11 in AWS, or will it have some issues versus DigitalOcean, et cetera, et cetera. And then on top of that, Docker Compose is a tool for defining and running multiple containers, and you're able to turn really complex Docker Compose or Docker commands into a configuration file, and then use one single Docker command to go build all of the things, and all your configuration is inside of a Docker Compose file, right? Anytime we can take a really complex command and turn it into a config file, we're happy, right? And I'm not going to dive into how exactly we do this. I will dive into the implementation that I use inside of Terry, but I won't talk about how you build containers and how you build a CI/CD pipeline for containers. However, I will give you the subtle plug. I do have a blog, and if you're ever interested in taking the dive of why I need to containerize if I'm a red team, why is it valuable for me to containerize, you can go check out my blog. I have a series where I'm talking exactly about those things and how you can even build CI/CD pipeline for your container images. So now you just have container images that work. And if your team, if anyone new comes on board and you're saying, go play around with Cobalt Strike, I'm sure that you've told your team, anyone new into red teaming, go play with Cobalt Strike. Now they don't have to fight with dependencies. They don't have to fight with installing stuff. They just go pull down a container image and it runs. Everyone's happy. Cool, so back to Terry. So what Docker and Docker Compose now allows us to do is the original Docker command to spin up something like Demos C2, which is a C2 framework that we've used against Mac OS, is we take this really complex Docker run command, and then we can convert it into a config file. And now we use one single command to basically, no matter what we have in this config file, we use one command to deploy all the things. And that's great. So then how I implemented that with Docker Compose and Terry is we now have a way to deploy multiple containers onto a server using a single config file onto our servers. But not to mention, we have an extra added benefit here. Now we have the port mappings. Because we're telling in the config file exactly what ports need to be exposed, I can go look at that Docker Compose and say, oh, look, I have 443 open. I probably need to open that up to my team, right? That gives me a lot of power, so I can now programmatically set the host-based firewall based on the Docker Compose file. That gives me a lot of awesome benefit. So what that looks like in practice is Terry can now have a master Docker Compose file with all possible containers that we can deploy. And then in the CLI, I can programmatically parse that Docker Compose and say, oh, well, I see Cobalt Strike. That's probably an option that I want to expose to the user as an argument they can pass in. Now, this is where I'm going to ask someone in the audience to help me understand what is wrong with this picture. Because there is something wrong. If this is my config file for all of Terry, for every single thing that gets deployed. And I know that this is probably an edge case for some of you red teamers, but when you deploy Cobalt Strike, you need to pass in runtime arguments into the team server to make it configured to run a certain way. So what's wrong with this as a config file for Terry? Can anyone answer that? There are prizes on the line.
I don't know how you configure your Cobalt Strike container, but potentially C2 profile you pass in might not be in the container. You have to have a line for that.
Exactly. That and this IP address, right? The container and what kind of prize do you want? Lockpick set?
Sure, yeah, that'd be great.
Thank you. But you're exactly right. We have runtime arguments that are going to change based on where you are. And we don't necessarily want to have a hard-coded password because we care about operational security. And this 8.8.8.8, that is a IP address that is used inside of Cobalt Strike to say exactly where the team server lives. We do not want that hard-coded either. And if we're deploying it in a container, the container IP address is going to be different than the host IP address. And that's really important. So the realization here is we're hard-coding credentials. We're hard-coding runtime arguments. But we don't want to do that because this is a master config file for all of my deployments ever. I don't want to hard-code that stuff. And this is where, I don't know if anyone can see where I'm going with this, but we've already gone into a topic that we can reuse here. Templating. There you go. And inside of Ansible, Jinja is already baked in. So now we already have a love story. Like we have Ansible that already uses Jinja. Now I can basically take all of the core functionality of Ansible and put Jinja templating inside of my master Docker Compose, and then basically just dynamically render those templates and then deploy them to servers. And this is great. But I'm curious, does anyone know the problem with this? We have one single Docker Compose file with all of my possible deployable containers, but a user might only want to deploy a select number of containers. If anyone has used Ansible or Jinja in the past, you know the issue with this. Can anyone answer that? Okay. This is where the breakup story comes in. If we're not deploying Cobalt Strike to a server, but we're trying to render this template, Ansible's still going to read in that template and say, oh, Cobalt Strike password, I want to instantiate this, but what if that's undefined? What if I'm not deploying Cobalt Strike? I'll give you a spoiler, Ansible gets pissed. Ansible will just yell at you. It will not care that you don't want to deploy Cobalt Strike. It will just say, you're an idiot, you don't know how to develop, get out. But, again, deja vu, I'm a hacker. I can bypass this. I can figure out a different way. And I can rekindle that love between Jinja and Ansible again. And instead of using that valid Jinja syntax, why not use my own custom syntax and then parse through based on what the user told me the containers they want to deploy are, parse through the Docker Compose, only collect those pieces, write those out to disk, use some regex to parse through the custom templating syntax that I had built, and then re-import it back into Ansible. That way I know for a fact I only have the container inside being rendered with valid Jinja that I really care about. So if you get yelled at that point, I hate to say it, but again, play stupid games, win stupid prizes. Trust me, I've done it so many times. I'm at fault for this. But so what this looks like, now that we have this kind of custom templating syntax, which essentially, so Jinja is curly brace, curly brace. Here, now we have square bracket, square bracket. So what that looks like is inside of our master Docker Compose, we have this square bracket for all of our valid Jinja syntax. And then if Cobalt Strike is configured for that server, or if certain C2 is configured for that server, we can modify the template syntax using regex and re-import that. We can do that all inside of Ansible. And this is super cool. This gives us a lot of awesome functionality that gives us a lot of flexibility to how we want to build all of our red team infrastructure pipeline. But again, as you pointed out earlier, what about those containers that need specific files or commands to run? And yes, I'm looking at you, Cobalt Strike. Can anyone, I think you kind of already answered it, But can anyone else in the crowd answer to me, like, how we might do that?
So like you're saying you're creating all this in Python originally, so couldn't you generate a script file located somewhere temporarily, and then after the container is made, import it there and run it automatically in some fashion?
Yes, you could do that. Not exactly the approach I had, but I'll give you a point for it anyway. You get to pick. Which one do you want? So yes, exactly that. I went about it a different way, but you can do it that way too. So what I decided to add inside of this master Docker compose that I already have is add an arbitrary block for pre-run commands and post-run commands. So some containers, based on what you're dealing with, might need you to run commands before the container boots and then after the container boots. So I'll give you the example of Sliver C2. Sliver C2, if you want people to be able to connect to the container, you need to first start the container, or first start Sliver, and then you need to generate the configs so that all the users can connect to it, because all of the keys generated for the configs are dependent on Sliver already being started. So now, within this custom Terry Docker Compose, we have this pre-run commands and post-run commands blocks. These blocks contain valid Ansible tasks that are run pre and post container start. And they too contain that escaped Jinja syntax that we talked about earlier, so we know that only the defined things will be rendered at time of import. Now this is probably for a bit more of an edge case, but how can I connect all of my infrastructure together when not all of it is directly connected to the internet? So if you remember back to my initial kind of dream state, I showed you that there's a server in a private network, and that server in the private network, I want it to be able to communicate with my HTTP redirectors, but I don't know how to route to it, and I don't want to manage all of my port forward rules at the firewall. I just want things to work. And this is for some of you overachieving teams that might have a dedicated lab environment who are really kind of crazy about controlling their infrastructure, and this was the bucket I found myself in. This is where I wanted to control all the traffic that's going to my servers, even things that are in a private network. This is where, earlier I talked about installing a tool called Nebula. And this is where I'll talk about Nebula. So Nebula is a Slack developed, so the team over at Slack came up with this solution, and it's a mesh VPN solution that uses the same protocol as WireGuard. It's basically a software-defined network. And there's a lot of different solutions out there that you might have heard of, like Tailscale, that'll do the exact same thing, but Nebula fit the use case for me the best. And what Nebula allows for me to do is NAT punching. So even firewalled resources inside your private network can be directly reached from the internet if connected to the mesh. So now I have my servers sitting in a lab closet back in Cincinnati, Ohio, that's able to connect back to all of my infrastructure that might be sitting in AWS across a VPN tunnel. And this is great because this also makes sure that if any of my traffic going from DigitalOcean to AWS or maybe back to my private cluster, none of the clouds see exactly what traffic is going across that network. They only see the things that come in from my implants, and that's great. So what this actually looks like is when we study the astronomy, Nebula, you see the HTTP reverse proxy has a direct internet connection, so it has a routable public IPv4. Then it connects to a Nebula Lighthouse. Think about that as your router. And that also has a direct internet connection. And then I have my C2 server sitting in a private network. That C2 server will initiate the connection outbound to my Nebula Lighthouse. When it establishes that connection, it's a persistent connection. So now I can funnel traffic through from my HTTPS reverse proxy to a private IP address that routes everything through the mesh. I don't have to worry about anything being connected. It just works. So it seems like I'm sitting almost on the same exact LAN as that C2 server, even though we could be 4 different clouds away, right? And that gives us a lot of really cool functionality. Okay, that was a lot of me talking about exactly what the hell this is. So let's talk more about kind of what the solution is. What does it actually look like? Because I just talked about concepts, but I didn't talk about the actual tool. So going back to this architecture diagram, This is the baseline. This is the vision that I had for a tool. I wanted something that could do this without having to think about the complexity. And can anyone tell me who might have done all of their different, like played with different clouds, played with different operating systems, played with all the things, how long do you think, and I'll give you one of the prizes for it, how long would it take you to manually go install everything here with all the things listed on the diagram? Way too long. I love that answer. And remember, we're lazy. We like to be lazy.
Absolutely.
So what I was able to do is take this exact configuration, this exact deployment, and now I can convert it into a command like this. So what we're doing here is we have Terry. We're calling it the operation, super secret operation. We're giving it the command of create. We're building a server in AWS of type Lighthouse, so that's our Nebula router on the internet. We're building a server in Proxmox, which is my private network that has my dedicated lab environment. We're going to install the container Cobalt Strike to it. We're going to install the container Sliver to it. We're also going to build a server in DigitalOcean of type redirector, with the redirector type being HTTPS, with the domain of c2.malware.com registered at GoDaddy pointing to it. And then we'll build a server in GCP of type redirector, but the redirector type being DNS and the DNS C2 being dns.evil.com registered at Namecheap. Right, so that takes really this massive problem and it boils it down into this syntax that's palatable for any level person in a red team. Right, so now I can enable my team to say, I don't want to focus on having to configure all the software. I want to go build malware, or I want to go research TTPs. I want to go do CVE research. Now they have a CLI so they can go deploy all the things to enable them to go do that research without having to worry about OPSEC, without having to worry about getting caught by other blue teams, without having to worry about any of the things that you might have to worry about as a red teamer. You just have a syntax that's easily understandable and you can feel enabled to go do the things. So I was going to do a live demo, but I didn't really want to have to pray to the demo gods. So I'll do a quick demo with some GIFs and kind of show you what this looks like in actuality. It's not the sexiest thing in the world, but it's still cool to show off that it does work, and it is a tool that you can go use and download off GitHub today and go use the thing. So also, quick side note, I have not implemented all the providers. I've been working on bug fixes and making sure that the core functionality works. So not all the providers used in that initial architecture diagram are the ones I use in the demo, but the same concept applies. So how it starts, and I realize this is very small, so I'll kind of walk you through it. How it starts is the user inputs exactly what they're looking for. Terry will parse through all the config files and make sure that everything that you're requesting is something that we have configured. So if you're requesting AWS, make sure that you have the AWS template and you can actually render that. Make sure that you have all of the valid credentials needed for each cloud provider. And then, honestly, if none of those things are found, so if you can't find the required credentials in the CLI arguments, or you can't find it in the environment variables, and you can't find it in the config, last resort effort is prompt the user for standard input. Say, I don't have this thing, give me the thing that you asked for because you haven't given it to me yet. So after Terry validates the request, it will then go through and build out my Jinja templates that's valid Terraform, and Terry will go build the Terraform resources. So Terry does this all automatically, and you actually have the option to say auto approve anything that's built with Terry, but if you want, you can just manually type in yes and hit enter. And then what that does is exactly what you expect. Terraform goes, interacts with all the clouds, builds all your things, builds the DNS records, having everything be dynamically referenced based on what you were asking for. And then after everything's built, Terry will read through the Terraform state that, of everything that was built, and then start to kick off some Ansible plays against those hosts so everything gets configured. And also, we can generate all of our Nebula certificates so that we have everything interacting inside of that private mesh VPN securely and fully encrypted, and we do that all through Terry, and then we can go deploy all the configuration and all the certificates onto the servers so that we have that mesh VPN set up, and everything just works. So now I can route things between the private subnet, and everything's happy. And then my favorite part is my team is very lazy, and we like to be lazy because we like to be malware developers, right? And we, after building these things, we don't want to have to copy and paste and say, oh, well, here's all the things we built. So what I did is I added a little cherry on the top of a Slack integration. So after everything's built, we can have Terry send a message off to your team in Slack saying exactly what was built and give you all the information you need to know as a red teamer to then have all of the data to go build your payloads. Right, so exactly what DNS records were created, what's the provider, what's the Nebula IPv4, what's the IPv4, what containers were installed, basically all the data you might need to know as a red teamer to go do the things. So that's my solution of Terry. And I want to give a call to action for you all in the crowd who might have an interest in doing some of this research. Because my goal as a developer is not done. Terry's a good start. It gives me a lot of the core functionality that I want as a red teamer to go build things without having to worry about the complexity of red team infrastructure. But for any of you who are interested in taking the plunge with me, I'm always looking for collaborators on the project. So reach out to me if you're interested in helping Terry grow and come talk to me after. This is a cool opportunity and there's still a lot more to be done, and I have a lot of really cool ideas for where it goes. But I am still a red teamer and I still have a day job. So I'm trying to kind of work and get more people interested in the project. So come up to me and talk to me if you're interested. And lastly, I want to thank all the contributors who have helped me get here. One of my old coworkers who worked with me at Fifth Third, his name is Andrew Whitmer. He gave me, as I was struggling, he wanted me to struggle and then finally get to a point where I had to reframe the problem. And once I reframed it, he then handed me kind of the bones of what he had thought is the end goal for a red team infrastructure pipeline. So he gave me the bones and I just ran with it. So I want to thank him for letting me run with it and kind of coaching me without just handing me a solution. And not to mention the couple of GitHub contributors I do have on the project already. It would not be possible without y'all. And also, I had to do it, so don't hate me if I actually am not supposed to do this, but I'm going to do it anyway. One of the cool things about where I work is I am allowed to go do this research. I have a lot of great leadership who I told them, I want to be lazy, I want to go learn all the things with cloud, but I want to do it during work hours. And leadership was like, hell yeah, go for it. And I want to say it's been awesome to work with them, and we are always hiring, we're always looking for new people, new talent. So if any of you all are interested in taking the plunge deeper into cyber and you want to do it from a financial perspective, come talk to me. We're always hiring. And also, you can even just go look at our careers page. But I had to do it. That's pretty much it. I want to say thank you. Special thanks to all the people who have helped me with this solution and the feedback. Again, it's not possible. And thanks to all the B-Sides people for putting this on and letting me talk. I'll be honest, this is my first presentation I've ever given at a cyber conference. So kind of cool that people were reaching out to me and are supporting me in going through this journey. But if you want to talk to me, just on the internet, you can contact me on Twitter @BuckinghamEzra. You can contact me via email, ezra.buckingham@gmail, or you can go to my blog, ezrabuckingham.com. And that's it. Thanks, everyone.
Do you want some questions?
Oh, I'd love questions.
So despite all those names on the screen, this is Quaid, to be clear. This is Quaid.
That's me.
And you do have microphones in front of you. You can press the little button, the light will turn red. Ask your question, press the button to turn it off. So if you have questions for Quaid, please
We just ask that
press that button.
repeat the question so that way it's
Yeah,
recording.
got it. Yeah.
How does the solution work with dynamic infrastructure? So say you have a DNS set up, a redirector set up, that gets burned, you want to set another one up. Can it do that dynamically?
So the question was, if I have infrastructure that gets burned after I've built it, how can I modify my infrastructure to address that solution? So yes, kind of. So inside of Terry, I did think of what happens if there's scope creep. So what if you say, I want to go build a new redirector, but you might want to keep some existing ones alive. I don't have it here, but there is an ability inside of the tool to, instead of run that create command that I had earlier, let me see if I can pull it up real quick, somewhere. Stupid transitions. Cool. So you can see that create command instead of create, you do add. And you have the operation be an existing operation that you've already built, and then you can add redirectors, and you can even point them to resources you've already created. So cool enough, like what happens is every time you create a server, it's assigned a random server name, and that server name can then be referenced by other resources. So if you want to, in that redirector config, you want to say, okay, that DNS redirector, I want that to point back to my team server. I can name this team server something like server McServerface, and then down here, I can do R2 server McServerface, and then that inside of Ansible will automatically map those two things together and say, okay, if there's a Nebula IP, I want it to route to that Nebula IP, but if it's a public IP, just route it to the public IP. So most of the configuration is done. So if you have things that get burned, absolutely you can spin up new infrastructure, but you don't have the availability to deploy select pieces of resources, because Terraform might not like that. And I figured managing that kind of a PITA, but good question. Any other questions? Yeah. Yes, that's a good question. So the question was, I had Docker and Terraform sitting side by side, working independently. Why didn't I just use the Kubernetes functionality inside of Terraform? And to answer your question, I wanted to have kind of two separate worlds. I didn't want to have Terraform baked in with the host configuration. I wanted to have Terraform just go build the things and then have Ansible configure the things. Right, so now I have a separation of resources because there might be some sort of need in the future to say, I want to rip out Terraform and I want to build something else. Or I want to use something else to build all my resources. Right, now I can do that and I have everything kind of siloed into their own solution, so I can say, let's say I tomorrow wake up, like I had a boss, he told me, why the hell are you using Ansible? Go use Salt. And now with this solution, I can say, okay, I can rebuild everything in Salt, but like, why would I? There's no real competitive advantage to do that, but I could. And I don't have to rip all the implementation out. I just have every little siloed instance to go do the things. But that's a good question.
You know, given your background as a cybersecurity researcher, I'm very interested in what cybersecurity threat targeting our nation's polarized democracy concerns you the most.
I'm not sure, so I'll ask a question, or I'll repeat it. So one of the things that he asked was, given a security professional and given a security researcher, what are the things that I'm worried about that against our nation? I don't know if I have a good answer. I'm still, like I said, I started not too long ago, so I'm still trying to figure out the threat landscape. I think that's something that I'll probably be better equipped to answer, but I don't want to give you an answer without having a better understanding of the threat landscape.
And just a technical question. So this configuration you described, does this apply to an organization that has resources across the globe? So an AWS organization, for example, that would have VPCs in multiple countries, multiple AWS regions?
Yeah, so the question was, how does this apply to people or organizations that have VPCs or different resources across different regions in AWS? To answer your question, yes. So the whole reason that I wanted to do all of this research was oftentimes my threat intel team, they'd come to us and say, oh, well, you guys are going to try to emulate Fin7, right? And I'd say, yep, we are. And then I'd go ask them, what are the hosting providers, or what are the different infrastructure, or where do they deploy their infrastructure? I wanted to have a pipeline to go mirror that of the Fin7s of the world or the other APT groups. And I wanted to do it in a configurable way. And this is the solution I came up with to do that. So I can emulate Fin7 infrastructure, or I can go emulate UNC 2529 infrastructure, or do that all using a single config file or using a single CLI syntax instead of having to go figure out how all the different providers work. And now I have an extensible framework to go do that.
Thank you.
You're welcome. Any other questions? I almost don't want to call on you. All right, Dan.
Given that Terry, like you said, is a lot of ways geared towards newer red teams that are kind of figuring out the tools. Do you see any potential for like a kind of Terry-centric documentation that gets generated alongside whatever you're building?
So the question was, given the fact that Terry is geared towards red teamers, do I have any plan for developing Terry-centric documentation for the things that are built? Is that correct?
Yeah, particularly around like, hey, you just made, this EC2 instance,
Yep.
running these Ansible playbooks,
Yep.
they may not know what that is, to have that kind of be explained in a friendly way.
Yeah, I'm still trying to work through that because there's a lot of different solutions here. Like, we're talking about Ansible, we're talking about Terraform, we're talking about Docker, we're talking about Nebula, we're talking about Elastic, right? There's all these things that you can dive into. I'm going to try to cover those things in my blog. As far as documentation for resources that already get deployed, because of the unique state of Terry and building things on top of Terraform, I don't want to steal the thunder away from the Terraform state and basically all the self-documentation that comes along with that. But I do have a custom, I'll call it Terraform state, that I build across all of these resources, so I can say exactly what Nebula IP was already used, what's the Nebula cert, what are all the things that I need to know if I want to add to the deployment or if I want to add things to it. But as far as general documentation, I do have some pretty good documentation on the GitHub. I'm still working on like how that actually manifests because there's so many different things I can document. More to come.
Cool, thanks.
And he's on my team, so that's why I'm giving him crap. Yeah.
I'm currently working for the U.S. military. I mostly do incident responding and incident handling.
Yep.
And I'm wanting to transition more over to red team. So I was going to ask you, what would your advice be for someone who doesn't have any red team experience who's wanting to transfer over more towards like red team operations?
Yep, so the question was, I'm in the military, I'm in more of a blue team focused role. How do I break into red teaming since I'm interested in that? I have a lot of feelings about how people break into the industry as a whole. The answer that I like to give people is find a mentor, find someone who really cares about you as a person, make them, I'm gonna say it, but probably get in trouble for saying it, make someone give a shit about you. Right, and if you find that person, they will help coach you into the places that you want to go. And if you have that person, you'll never be unemployed the rest of your life because that sort of person will help make sure that you're going where you want to go and they're invested in you. And that's how I'm going to answer that question. I know that doesn't help you with the exact like red team, how you break into those roles, but having a mentor is going to help you learn from why you might not get into a red team role sooner rather than later. And having that support system is more important than getting into the role that you really want.
So I'll take advantage of the last question. That's great advice. Would you maybe share a story about how someone poured into you, how you made someone care about and invest in you?
Sure. So the question was, how did I find someone who invested in me? So I started off my career, I did kind of freelance consulting in college. I graduated back in 2020, so I have kind of a different background. Did some consulting, started getting really, I'll call it like well-versed in different roles, like data analytics, business intelligence, web development, all that background. And then I went into a leadership program because I didn't really know where I wanted to fit in, but it was an IT-focused leadership program. And I went into that thinking, I don't know what I want to do. I want to figure that out and use this as a means to do that. Through that program, I kind of had a support system in place, but I wanted to branch out even more. Because once I started feeling like cyber was the way to go, I found that one person in cyber who was investing in early career pipeline people. And I just started asking them questions, barraging him with questions. And he has been my mentor ever since because I just started asking him questions and then he and I developed a relationship, kind of a personal relationship, and now I go to him with any sort of questions. So it started off, just be curious. You ask people enough questions and they'll start to be like, oh, well, you know what? This person's curious enough. I might want to invest in them. might want to cultivate that passion that I see. So really, I have a lot of feelings on this topic. So if anyone wants to like talk to me about it after, I'm happy to talk through it. But I would say, be curious, go ask people questions, go take initiative, and that will set you up for success.